Okay, we're going to go ahead and, for the sake of time, keep moving on with our next session. I know we've got a lot back to back, but hopefully you'll see that they all kind of build off of each other. So my name is Caroline Bonis. I'm an AI engineer as part of our client engineering group, and I'm here with my colleague, Jeff Edgington. Jeff, did you just want to wave and say hi? Jeff's a principal solution architect, and together we're going to kind of have a new discussion or build off of the discussions that we've had this morning, dive a little bit deeper into our Watsonx platform and take a deep dive into the components that make that up. And then we're going to talk about a solution that Jeff has built that really illustrates the art of the possible, especially when we get into the defense space. So he'll be able to demonstrate some really exciting things that are made possible when you have a platform like Watsonx in place. So I wanted to take some time just kind of framing the discussion around AI and kind of the inception of Watsonx and what has kind of driven the product to be where it is at today. And really that kind of reflects the shift in the AI space that we've kind of seen and observed over the past couple of years. And really it's gone from a world where businesses are kind of doing business as usual and then adding some AI on top of it where they see fit, to a world in which AI is really in the driver's seat and at the forefront of a lot of initiatives across enterprises and organizations. And really AI is at the forefront of many strategic initiatives that we're taking right now. And IBM's POV is that the organizations that adopt this AI-first strategy, as we call it, are the organizations that are going to be the most successful in this new era of AI. So back to some of the basics just briefly, since we kind of have a different skill sets and people with different backgrounds in the room. What's driving this AI-first initiative is really the new paradigm that generative AI has established in the space. So for those of us that are newer or less familiar with kind of the structure and what generative AI has done, this is a slide with a ton of information on it. But on the left-hand side, we have the way that traditional AI models, or AI as we've known it for years and years, has worked, and how it is working now that we have this new paradigm with generative AI, or newer, I should say. So on the traditional AI side of things, you'll see that what was required was a specific set of labeled training data, and often lots of it, that was required to train a new model every time you had its own task. So this paradigm is really resource intensive from a skill standpoint and also data intensive, so really costly from that standpoint and also just time intensive. Because anytime you have a new use case for AI, you have to have the right data for it, and you have to train a new model for it. And that's how things have been done for years and years. But with foundation models, it's kind of flipped that concept on its head. Foundation models being kind of the fuel or the umbrella term for which generative AI is a subset of. But with foundation models, instead of having to have that new labeled data set and that new model every time you want to do something, you can take a much larger model that's been trained on a ton of different data and use it for your downstream tasks. So you can take the same foundation model and then tweak it a little bit and apply it across the enterprise and across different industries and be able to unlock a ton more value without having to have that labeled training data that often held us back in previous times from being able to achieve what we needed to achieve. So we have a ton of productivity and use cases that are therefore unlocked with this paradigm that generative AI and fueled by foundation models offers us. So I mentioned before that Jeff and I are both part of the client engineering team, and the client engineering team is kind of a fun and cool place to work because we get to partner with our clients in the federal space on their generative AI and AI in general products and projects, and see what their initiatives are, help them define what those initiatives might look like, and then co-create an MVP about them. And as part of that role, and in that role, we've gotten to work on tons and tons of projects with our clients. And Jeff and I are just, one representation of a much, much larger team that's done thousands of Gen AI products over the last year and a half. And as a result of all of that work, IBM's kind of continued to refine its POV on AI and specifically generative AI, and these pillars kind of make up what IBM's POV really stands for. The first is that it's multi-model, in that there's not one model that, even though we have these big foundation models, oftentimes we still need a variety of those foundation models to be able to match them with the right downstream tasks. So sometimes a bigger model is more necessary or can perform a little bit better, but sometimes a smaller model can actually get us with a little bit more tweaking to the right place. Code models might work a little bit different than natural language models, image models, all types of things. So having a multi-model approach is really important. Second, IBM has long taken a multi and hybrid cloud approach, especially when it comes to industries like government or healthcare, where security is paramount, and you need to have oftentimes an on-premise instance to run these things in. You can't just do everything in the cloud. So supporting that hybrid cloud approach is always something that IBM is really keen on. Governance is something that is a newer or is a really, I guess, hot topic right now. Not new, but something that everyone's kind of contending with as they start to build out their AI use cases. How can we actually trust them and ensure that we can move forward with confidence and explainability and transparency? Because often what happens is as these models get more advanced, they also are more of a black box and are really hard for us to kind of defend and explain what their outputs are doing. Scaling for value just means being really selective about the generative AI use cases that you select for deployment. Not everything is well suited for generative AI, and sometimes just being a little bit pickier and selective about what use cases make the most sense is really important. And then lastly, as always the case with AI, data matters. So garbage in always equals garbage out. So ensuring that you have the right data, that data is secure, it's not going to get you into trouble, always matters. But also having a platform that serves up that data in a way that facilitates running these AI workloads is really important. So all of this leads me to why IBM created our platform for data in AI, which is called Watsonx. So when we talk about Watsonx, we're talking about a platform that has 3 subcomponents that were designed to meet the most pressing aspects of any AI strategy. So we have our Watsonx.data platform that's designed to help scale AI workloads and access all of your data regardless of where it resides in one place. It's built on a data lakehouse architecture for those who are familiar, and if not, I'll get a little bit deeper into that in a follow-on slide. Watsonx.ai is the one that everyone is always excited about and kind of the most fun to play with, but that's our studio for working with both traditional machine learning model frameworks as well as generative AI and foundation models. It's a really fun place and a kind of a playground for building all of these things, and eventually will be the platform that helps get them into production. And then lastly is our Watsonx governance platform. That is kind of the governing body behind all of this. Again, how can you build out these use cases, but ensure you're doing so in a responsible and transparent manner? So Watsonx.governance is a toolkit for helping build out those governance strategies. So to dive a little bit deeper into what these all actually look like, starting with Watsonx.data, it's our data lakehouse architecture that provides a fit-for-purpose data store based on that open lakehouse architecture. So I'll walk you through kind of the levels of this and describe what the platform actually does. This is a screenshot of what it actually looks like, so I won't demo it today, but I did want you to kind of see what's going on under the hood. So that bottom layer is the connection to your data regardless of where it resides. So it allows you to actually just make a live connection to your storage buckets or your databases that brings it into one platform without actually having to move anything, but kind of centralizes the access of all your data. Data siloing is a big kind of thing for organizations to tackle right now. So having a central platform to be able to manage that data is very crucial. On top of that sits our cataloging mechanisms that take advantage of open table formats like Apache Iceberg and help you create a metastore of that data that then those downstream engines can use without having to recatalog anytime you use a new engine. And then on top are the multiple query engines that are designed to help match the right workload with the right engine. So what I mean by that is that if you're running an AI-heavy workload, something like Spark might be the engine that you would want to do that on versus a Presto or SQL-based engine to run a more data-heavy workload. You want to be able to match those engines to the right workload, and in doing so, you get to optimize on both cost, which is huge, huge cost savings, but then also performance. So it's just all about making sure that your data platform makes sense for the workloads that you're running and enables the creation of these AI assets instead of kind of being an inhibitor as data tends to be, or can be, I should say. Watsonx.ai, I will just spend a little bit of time on this because this is what I want to demo for you all today. But again, this is our playground and our studio for working with generative AI and traditional machine learning models. It has a ton of different components that are geared at being both no or low code for those more citizen users that don't necessarily have a robust code-based skill set, but still want to be able to take advantage of the technology. While also supporting the users that want to be able to have that granular control and go in with a code base and kind of develop exactly as they would like to. We also have what's called our tuning studio that allows you to take different prompts for your generative AI and tune them so that they perform a little bit more expectant to what you want that output to look like, which is pretty cool. We have InstructLab, which is a very, very cool platform that essentially just brings the open source community to LLM development by allowing you to take advantage of things that have already been built and things that have already been done to refine your downstream models by taking advantage of what the community is doing and not having to rebuild it every time you want to do something. And then lastly, our platform also supports all of the data science and MLOps tools that IBM has long been supporting and enabling within our data science platforms. Dean talked a lot about this, or a little bit about this in his previous session, if any of you were able to make it. But our IBM Granite suite of models is something worth mentioning because it's really designed to perform for enterprises and is built specifically with enterprises in mind. And what I mean by that is that the data that was used to train these models is a very highly curated, what we call data pile from IBM research that is designed to mitigate any of the risks that maybe some of us have seen in terms of copyright infringement and IP popping up with the training of these models. So the idea with the Granite models is to provide a suite of models that enterprises can more confidently use and know that they are not infringing on any of those restrictions, but that it's also very curated for enterprise-grade use cases. And then lastly, Watsonx.governance, our platform for building out and accelerating all of these workloads to be transparent and explainable. So it's really designed to help enterprises meet the changing and dynamic landscape of AI policy and regulation. Things are kind of popping up all over the place. Oh, give me 1 second. I think my Wi-Fi disconnected. And I'll need that for the demo. So. Sorry about that. Want to be able to show you guys this in action. But Watsonx.governance is our toolkit. It helps you meet upcoming and dynamic safety standards or regulations that are popping up by taking the regulation and the policy that's being produced and translating it into actionable automation within the governance platform. So it helps you more proactively detect and mitigate risks, monitor your models for things like bias, fairness, drift, to help manage risk and reputation, while also creating what we call a fact sheet for the model, which essentially means that as any models are created in the platform, a fact sheet is automatically being populated to capture metadata about the training, development, evaluation, and eventually metrics from into production about that model, so anyone can come in and see exactly what's going on at any time. So without further ado, let me jump into the demonstration. I want to walk through a tour of our Watsonx.ai platform and kind of show you some of this in action. And then once I'm finished with this today, I'll pass it over to Jeff, and he'll show you kind of the art of the possible of like, okay, you've done all this experimentation and exploring in our Watsonx platform, but what is this actually, or what could this look like specifically with the defense use case? So let me jump right into our prompt lab. So the prompt lab is the space for working with foundation models specifically for text generation and generative AI. And there's a couple of different ways that you can work to essentially build out prompts within this interface. For those of you that might be a little bit newer in the the space or less familiar with some of the concepts, prompt engineering is essentially what you're doing anytime if you were to log into something like ChatGPT and ask it a question, you're technically prompt engineering. And you might have noticed throughout that process that the way that you ask your question gets a different or yields a different result. So being really meticulous about the way that we prompt these models can yield much better results. So the prompt lab is designed to help you do that more effectively, regardless of what your skill set is, so that you can kind of get the most out of these models. First, I just kind of want to highlight, I know this came up in the last session, all of the different models that you can work with in this platform. So you can see our Granite suite of models is well represented, but we also offer many open source models as well. You'll see some Llama models, and then Mistral models as well. And you're able to actually click into these models and get a really robust overview of how they were trained, what their intended use cases are, and some background information about the model to help ensure that you're selecting the right model for the right use case. That's kind of step one in all of this, is making sure that you're actually setting yourself up for success by picking the right model to work with. Once you've selected your model, you can then play around with the different prompt engineering in a number of different interfaces. The most intuitive or familiar way to us is often the chat interface. This is what would kind of mimic something like a ChatGPT interface if you've worked with that before. But it allows you to just kind of ask questions and answers against the model. My network has been so slow today, so I don't know if it's actually going to let me generate anything, which I apologize for. But you can imagine this being just kind of a chat-based back and forth. I'm going to stop this just so it doesn't eat up all my network. Another thing that's really cool about the chat interface is the ability to ground the chat in your own documents or do essentially what we call RAG, Retrieval Augmented Generation. For anyone that is unfamiliar with that, it essentially allows you to upload a document that is specific to the questions that you want to ask and tell the model to just generate answers based off of that document. So it's a really great way to kind of make these use cases more tailored to your organization. And being able to do that directly in this interface is super nice because it allows kind of non-technical users to essentially build out their own RAG architectures and RAG workflows in this nice UI. We also have a couple other ways to build out prompts. The structured section here gives you a number of different structured prompts to kind of kickstart based off of really common or typical use cases that we see. So for example, this is a classification use case that allows you to take a body of text and classify the sentiment as positive, negative, or neutral. You can play with the different parameters that output the results. This just allows you to have more flexibility in the way that the model's generating things. So greedy will ensure that the model's just taking the output with the highest probability every time, which is really good when you want to generate the same answer over and over like a classification task. If there is a sentiment that you want to classify, it's always going to be positive. So having that greedy turned on makes sense for that kind of use case. But other times we might want to be a little bit more creative and give the model a little bit more flexibility in its output, in which case you could turn on what we call sampling. And that gives you more control to be able to control the things or the outputs that the model considers in its response and kind of widens that net so the model has a little bit more flexibility in its word choice and its tone and things like that. And then lastly, you have just what we call freeform, which is kind of like the most sophisticated way of working with prompts because it gives you complete control to build out a little bit more sophisticated prompts. So once you get more comfortable with prompt engineering, this is usually where you'll spend most of your time. And then the last thing I want to highlight about the prompt lab is the way that you can take this work and save it. So a prompt template is something that once you've refined your prompt and you want to be able to use it in a downstream application, you could save it as a template that then could be applied to new data. A prompt session just allows you to capture all of the work that you did so that you can collaborate with people or show people what's already been done and just kind of save your work in the order that you did it. And then lastly, or my favorite aspect of this, is the ability to take everything that you did in the prompt lab and generate it into a Python notebook. So for an AI engineer like myself, this is a huge time save because it allows me to really rapidly iterate within this UI and then take my final work, generate a notebook, and instead of having to write the same code over and over, I just have that notebook automatically generated for me that I can then build off of, expand on, and embed into my workflows. So hopefully this gave you a good understanding of what's possible with Watsonx and the technology that's available, and kind of gave you a feel for the prompt lab. But now I'm really excited to hand it over to Jeff. Again, he's going to get a lot more specific in the defense use case and kind of show you the art of the possible. Thank you.
Bear with a quick transition. So while this loads, I'm Jeff Edgington. I'm a solution architect in client engineering, same team as Carolina. And I'm 24 years in, so I have a lot of experience sort of taking some of these technologies and approaches and putting them into a solution. We mentioned earlier co-creating, where we take one of our technologies and work with a client to experiment. Sometimes we do that cross-industry, where we hear common use cases. And that's something we did with this platform we call DSAS, Defense Simulation Analytical Service, where we worked with several different clients and sort of looked at what was common about what they needed, and then created a platform approach that embedded Watsonx, AI, governance, and several traditional AI ML capabilities to weave it together into an overall solution. And so what Defense Simulation Analytical Service attempts to do is to start with providing situational awareness for the user. And I'll show this. I'm not going to PowerPoint too much here, but I just want to give some context. So we start with the problem of joint all-domain command and control, and trying to bring data together so that we can get insights out of it very quickly in a cross-domain fashion. So that's a mouthful, and it's not as easy as it sounds, right? But so that implies that we need to be able to connect to data and bring it together and raise those insights up and be able to visualize them in a way that it's easy to understand. Most of the users in this space need to be able to see the insights very quickly and in the context of the mission that they and their responsibilities that they have to carry out. So situational awareness is sort of step one, but we want to be able to bleed into decision support and being able to actually analyze courses of action. So think about being able to consume like op orders and planning, and then being able to interrogate that with some of the techniques we just talked about. So that's kind of the goal of what DSAS does. We, again, from a very high level, if you look at the left-hand side, it's basically connecting into all kinds of different data. And then that blue stack in the middle that sits on top of the red hat layer means that we can deploy in any environment. And in fact, hybrid is the most common. So we would have a local, often on-prem, even at the tactical edge footprint, and then often connecting into sort of a more command and control environment that has full cloud capabilities and a larger stack potentially. And then that blue box is kind of where we have our Watsonx capabilities and then our traditional data and AI and ML, as well as workflow capabilities and security and threat management. We sort of bring whatever the use case demands, and I'll show you a couple different examples of where we've taken this to more of a strategic type of user and then down in the tactical type environment as well. So kind of from a history standpoint, we created DSAS as sort of IBM's answer to joint all-domain command and control. We did this in like 2021. So we were looking at Russia-Ukraine pre-invasion. And at that time, it was heavily reliant on open source because Russia was posturing. There were a lot of kinetic activities that were threatening, but they weren't actually invading yet. So we were doing a lot of analysis of bringing in the information domain to see when it would trigger the kind of indicators and warnings that might allow us to predict when they would actually full-on invade. And so we were using this tool in that context. Then post-invasion, we pivoted to China and Taiwan just to look, same thing, look at the tensions so that we could look at not just the kinetic, because there's a lot of tools that are analyzing kinetic activities, but what about open source, news, social media, and cyber? So I have an environment that we'll walk through that looks at that sort of theater-wide context in Taiwan and China, and we do that for the context of a couple different personas. And that's key to what I'm gonna show is how do we take these technology approaches and put it in a way that's palatable to the user in the context that they need. So this is representative of like a commander's dashboard that's sitting in like a joint all-domain command and control type of environment. And I'll show this in a live environment just in just a second. But the gist of it is that you'll see behind it, to build a screen like this, there's a lot of capabilities that need to feed these insights. So we're looking at data that's cross-domain and being able to then visualize it in quick summary fashion, geospatially, and then even to provide status to some of their critical information requirements. So basically their KPIs of how they're doing it as a mission, we're able to look at the data and then raise up how are they doing and measure it. I talked about being able to apply that platform at different echelons or for different users. Just this last year, we did an exercise where we brought this down into a tactical environment where we use the same approach but different data and different users. And here we were looking at, it was kind of an experiment with the Army where we looked at being able to evaluate 2 different courses of action. So same situational awareness requirements, but being able to say in planning mode, what are the characteristics that make up the course of action 1, for example? And here on the screen, I'll show this interactively, but it's like a northern route or a southern route, and they both have different terrain characteristics and they different vulnerabilities that would be exposed from a red force perspective. And how do we evaluate that using these techniques? And so that gets into some, not just AI governance, but even some compliance so that we can actually measure the risk and report that risk back to the commander in a way that's, again, palatable. So a report like this, there's some traditional analytics that are bubbling up from the risks that have been captured, but there's also Gen AI to be able to summarize kind of the results of all this work so that it's explainable in a way that's palatable. I'm going to toggle to the if my network cooperates, which it doesn't look like it's going to. So instead, I'm going to go to a more local environment, and I'm going to show the tactical environment first. So you saw the screenshot a second ago of the commander's dashboard looking at the whole Taiwan, China sort of space. But here we brought it down to more of a battlefield. And so, yeah, this is somewhat connected to the internet, it looks like. So what we're doing is looking at, in real-time mode, where are all my units on the field, and what are the threats that we've detected. So that's sort of what you see here, if it lets me click. And these red dots are like alerts that have happened or been reported from the field. And these red circles are the 88 coverage. So the ability to both have radar that can detect where things came from, and then our ability to shoot down things that are, and so this is sort of from the context of protection is this use case. So how do we be able to protect our mission? And if in this case our mission is to do a breach operation. So we're trying to knock down a bridge, create a bridge, or get across a minefield. And to do that, we have to deploy engineering units, and our goal here is to protect those units. So when I say it's from the context of protection, how do we make sure that our key assets are able to fulfill their mission and protect them at all costs so that they can complete that? And so that's what we're looking at, is the sort of real-time view of where they are on the field and what threats and alerts are coming at them. And then the bottom are just a non-geospatial way to visualize those. I'll drill into one as an example. And this is kind of where we can talk about how do we orchestrate tasks based on the analytics that we found. So this particular alert, because we're looking at protection, we worry about people that encroach the battle space from the rear. So we saw a bunch of people walking back there, and it just means they need to be evaluated. Someone needs to go out and make sure that they're not going to threaten the troops from the rear area. So this got routed to a user. It's got a calculation on how severe the situation is. And all throughout here, when we talk about human in the loop, we want to be able to evaluate and provide feedback into the model of that I agree or disagree with this particular analysis. And then I can kick off a workflow to actually respond to this. And most of them may be just to further evaluate, but it puts this issue onto someone's desk that can respond. And then we can track their tasks and their completion of those tasks so we know that things got handled. And that can be raised up to other levels or put on someone else's desk, et cetera. And then we do this all in the context of their key assets that we're trying to protect on the bottom left. And then we look at where their mission is and what's been already completed and what is coming next and any decision points that need to be evaluated before we take the next move. In order to get to this place, that's where we kind of go back to this COA risk analysis. I'm going to go a little deeper. Here we're looking at 2 different courses of action and being able to quantify that risk. And that's a result of looking at all this data and evaluating it against these courses of action to flag where are the risks throughout that course of action. So if a course of action has a timeline of phases, like we'll break it down into 4 phases, let's say, we can evaluate the risk to each unit at each phase of that plan. So this is kind of the result, I'll say the punchline that the commander's gonna want. And to be able to build this, again, we have to have done the work to score that risk. So how do we do that? I'm hoping this is gonna load. Yeah. So in order to be able to score this, and this map may take a second to load through, but what we can do is visualize the course of action across those phases and even toggle between each course of action to see what the difference is, and then light up the threats so that they can actually evaluate. So this is based on doctrine, so we've consumed doctrine on the way to approach threat analysis and risk analysis, and then we visualize it so that they can actually look at it and see where are the risks and relative to these units that are a part of our mission. So here, for example, I can drill down to each individual unit and see, like, as you see these ones that have a red bubble over them, they're covered and protected with redundant coverage. So we're just visualizing that, but the data behind this reflects that visualization and that value. So when we talk about being able to see a report like we saw earlier, where the risk analysis is bubbled up into a bubble chart of kind of red, yellow, green, these values come from this assessment. And interestingly, when we talk to the Army about this, there's a lot of institutional knowledge on how risk assessments are done, but there's not a lot of data that's actually stored in this space. So we can, for example, look at and automate weather. I'll use weather. Weather, we can say it's bad, right? It's going to rain, and that's going to impact our mission. But is it going to impact our mission positively or negatively? Because it would also impact our observability, which might help us if it's raining. It might slow down our mission, though, which will put us at risk for longer. So those types of data points we can feed in, and then because we're storing them into the risk assessment, we can look at it over time to see, did that bear out, and can we further automate so that we can start to say weather is bad and it's also high risk for this particular mission. So when we put this in the hands of users, they found this very useful to be able to visualize these and even simulate different conditions. So we can look at, what if there's a chemical breach on the field? Can we look and see, yeah, the network's not really great, but we can see the plume and basically see which units would be affected by that. And again, that quantifies then the units that are at risk. So we can come up with a quantifiable assessment of, 10% of our troops were directly impacted if the plume happens in this particular field, versus in another area where they may not be able to get away from it as quickly. And then we can look at the mitigations as well. So if there is a chemical attack, for example, do we have the right gear? Do we have access to water? So can we mitigate that particular threat in a way that we can get through it faster? One other thing. So I'm going to switch users just to show kind of the role-based access of a platform like this. So I was kind of more of a commander. Now I'm a staff analyst that needs to report that risk back up to the commander. Same set of tools, but expanded audience. So one of the things we looked at was how do we use optimization. So what happens if one of our radars go out? It has malfunctions or there's an EW attack. And can we recommend repositioning based on a lower number of assets? So that's kind of what this is showing is if something on the battlefield changes, can we more or less reanalyze the course of action and redistribute our resources optimally? So we did this for radars, basically. How do we get the optimal coverage for our protected list of assets that we need to monitor so the mission can complete? And then we also did it for things like sensor placement. So where do you put your chemical sensors on the field to better cover where your course of action is going to travel on the battle space? So from a user standpoint that has to do this risk assessment, again, visualizing this was very powerful. That was indeed their requirement, is that they have a geospatial tool to be able to visualize all of these insights. But what we found, and this probably won't work, is that by applying just a Gen AI agent that's looking at some of the same data, instead of visualizing it, they could just ask. And that uncovered what comes down to a very big problem on how this works today in many of the agencies we talk to. In order to get a lot of the data that they have to manually go get it, right? So it may be sitting on a shared protected drive somewhere and published, and so a staff analyst that has to go look at the risk today, and this is pretty common to a lot of the different agencies we've talked to, they spend a lot of time actually collecting data. Like, how do I go find it so that I can read it and then look at it? So if we can automate the collection of this data, like monitor it like a hot folder, for example, and then we would be able to know when it's been updated. So like an intelligence report. The intelligence report might be old. Can we monitor that and say, this is pretty old data. We need, maybe need a new recon to tell us where the red forces are. But then exposing it with just, again, kind of a RAG-based approach, can I ask, what does the terrain look like, and just get a response? And then this is kind of an example of, do we build a UI to be able to navigate through these, or do we build the ability to interrogate? And the answer is both, usually, because it's a user preference kind of thing. So we created this staff assistant, which I left a copy up that was still running. And so all this is doing is RAG-based search against the data that they have access to. So there's a data governance piece at play here that's very relevant. Does the user have access to certain types of data, and how do we restrict that based on who they are and what operating environment they are in? So this is a kind of an easy example of doctrine, because it's not controversial, but a different user could have op orders or intelligence reports, et cetera. But all I'm doing really here is asking a prompt. In this case, I'm asking a question about how do I conduct a wet gap crossing, so a breach type operation, and what risks and factors do I need to consider as I'm approaching this. And so what I get back is that RAG summary, and then importantly, for this particular user, they need to be able to prove it, where did it come from every time. So we show the excerpts from the actual source. In this case, if I scroll down, you'll see that was kind of a lot. So that quick summary is very helpful. But I can see have the lineage back to each one of the documents and where it came from, and then even be able to drill down and visualize it in the same interface. So this kind of helps with the trust. Of course, we have governance to be able to do, if y'all have been in this room for a little while, a fact sheet so we can monitor the integrity of these models. But being able to visualize it and bring it to the screen for the user so they don't even have to go do that is also a way to be able to build the trust in the analysis and the system. So I brought that up mostly to show that when you build a system like this, depending on the user, a lot of it needs to be tailored to their specific workflow. Because if you don't, you have to teach the user how to use the system instead of having the system be tailored to the flow of the person that's going to use it. So each time we have an instance of DSAS, there's a lot of co-creation that's really about tailoring it to how do they do their job function. And then there could be different instances and different users for different roles. But that chat agent and the staff assistant are ways where they can get answers without having to navigate through screens. I'm going to talk for just a minute about how do we scale this, because this often comes up, and how do we have an environment that we can bring these capabilities to that may not be in a command center. So on the left-hand side, what I'm looking at is sort of this user's deployment environment. So it's the tools and data that they're using as they navigate the system, but that needs to change as they move into different environments, and that have more capabilities, more compute power potentially, and definitely different data and AI requirements. So I can go to a marketplace of available data and tools and drag over, as just kind of a business level user, non-technical user, the data sets that I need to consume. I'm just going to talk about data now, but this could be new models. So as as an example, if there's a new visual AI model that can now pick up some new equipment, Red Force equipment that we want to look for, once that becomes available, we can drag it into the environment. And then the orchestration can be automated, so all of the classification audits and policy audits can happen kind of as part of the policy check. And if it passes all of those, then it can, because of sort of the microservices and open architecture, it can just be orchestrated in and be made available. And if it failed any of those checks, or if it required to be wired into a model, it would kick off the workflow to that particular user to be able to do it. So it's not that everything will always happen automatically, but it doesn't require a project to analyze the requirements and figure out what it is. A lot of times this is relatively seamless, and a user can be in charge of just saying, hey, there's a new data set, I need to make it available. So really quick, I'm going to toggle to this other environment and hope that it works enough to show it. This is the Taiwan environment. But when we're talking about the risk assessment, let me see if this comes up. Good. One of the feedback we got is it can be pretty tedious to go in and mark the risk per unit, per phase of a plan when you're analyzing the course of action. So how do we assist in that? And so we've been working with like gaming engines to be able to run simulations. And then how do we marry the results of those simulations to a risk analysis so that we can actually store it as a risk assessment? So what we can do then, earlier we saw the ability to compare course of action 1 and course of action 2. So we just break down all the different options that would be relevant to help factor into the risk. Like, what does the weather look like? What is the maritime conditions, since this is sort of a at sea relevant terrain? Where are the red forces and blue forces that we need to be concerned about? And sort of feed those in as a posture. And then we can view a simulation, and it'll come back and show us, like it'll run all of those automatically or overnight. And then you'd get back a summary that you can then save as an assessment. So it's basically automating some of the wargaming that happens today, but being able to take that wargame and say, this overall aggregated shows me some risk, and I'm gonna actually capture that risk and save it off so I can compare it and go back and look at it later. So I think the only other thing I guess I would show is how weather comes into play. And here we just look at not just current weather conditions, which we can pull in real time to get current and forecasted, but to look at climate over time. So as we're planning a course of action, can we pull in and say, if we did this next month or next week, are there vulnerabilities in this region that might impact our mission if it isn't in the forecasted weather, for example? So are we looking at a region that is prone to flooding? If we had a kinetic activity that we planned on using ground transportation, maybe that would cause it so much of a delay that it would create an additional risk. So how do we factor those things in and then be able to interrogate it quickly so that that is one of the factors of our course of action? So I think I'll kind of wrap with that just to, in the interest of time, to sort of summarize with a lot of the technologies that we've showed so far are good ways to run experiments and get quick insights, but a lot of the users that we talk to end up needing a whole solution that these fit within. So things like the prompt lab, we see users that actually are using that, but it's a tab in a broader solution. So they're able to interrogate freely and change models and get different insights. But a common user out in the field needs something that is very, very easy to navigate, where the results sort of come to them in an easy to consume fashion. And that's kind of what the goal is of what we've done with DSAS. So I'll kind of go back to a friendly, non-broken interface. Any questions?
I'm just curious, when you were tracking resources from one side to the other a moment ago,
Mm-hmm.
what was the purpose of having those subsets? Was it because, let's say on an endpoint, it could only consume or operate with so many assets?
Yeah, so a lot of times this question comes up because they're in a field environment, like a tactical edge, where their compute capabilities are smaller. So they need to scale down versus when they get into a more compute-heavy environment or where they can connect to the cloud, they can scale up their environment. And the same thing goes with data. So they're in an environment, they learn that the situation has changed. So we go into a new geo area, we need to pull in the infrastructure so that we can see the roads and highways. So we need to pull in additional data sets very quickly. And so that's the idea, is that it's sort of our way to acknowledge that their environment changes all the time. And we can't build a system that they have to turn it off and have a meeting and reconfigure it every time that something changes. Okay. Thank you.